All right, today's the first lesson, a comprehensive math class, and in this course, we are going to study, go over or study various type of problems. And what I'm trying to do is every time I focus on one topic and discuss the problems, and you are given a set of previous math counts problem, either chapter or statement at that level, and we're trying to finish it within a week. And if there are a couple of problems you couldn't do it, and please submit it to me before Sunday, right? So I can discuss it in next class. If does not fit, the topic I'm going to cover, and I will record it and I will discuss in the following lessons. Okay. And if I ask you to work on some problems, given you a couple of minutes, and you please do your best to work on the problems. And when you have an answer, click my name, which was host, and submit the answer privately, so you are not bothered. Okay. So background is noisy. I don't know. Maybe my computer is running. I don't know. Yeah, the computer is a fan. I think it's. Yeah. I hope it stopped real soon. Okay. Okay. Well, I begin with the following problem. It's called the series. Okay, geometric series. This is first of all, let's understand n r to the n's power. Okay, this one, and this is called, we are going to talk about limit concept, the limit. Okay, and I want to see, how does it approach when n is getting larger and larger. Okay, so my claim is, here's the important factor in mathematics. This if the absolute value of I is less than 1, then r to the m, okay, approaches 0 as n approaches infinity. Okay, so how do you understand this? For example, I is going to be 0.1, right? Okay, let's look at right, 0.1 square is going to be 0.01, right? 0.1 cube is going to be 0.001, right? And then just keep it going, 0.1 to the 100th power, and you see that, right? 0.1 to the 100th power. So you have this 100 digits here, but this is a really, really very tiny small number. So that gives you some idea why this, why this sequence of numbers approach 0. So the limit case, we say what case? The limit, then in this case, we say the limit is Im. Okay, then we say that the limit of 0.1 to the n's power, okay, as n approaches infinity is 0. Okay, now here we have a notation. Yeah, the notation in mathematics we call it LIM, and this is denoted by LIM, 0.1 to the n's power, n approaches infinity, and that's going to be 0. Okay, so anyway, so we can also translate this above sentence into a mathematical symbol. Okay, so this is a rewrite another fact. So if Rn approaches, if the absolute value of R is less than 1, then we say that the limit of R to the n approaches infinity is going to be 0. Okay. All right. Then we consider a geometric sequence. Okay. A series. So we consider this one R1 plus R squared plus R to the nth power. Okay. Now this one, okay, it's finite. Doesn't matter whether R is greater than 1 or less than 1. Okay. It doesn't matter, right? So you can, how many of you remember to combine them into one fraction? Okay. So if you don't know, yeah, the question is, can we shorten? Right now we have to put 3 dots in the middle, right? Can we shorten the expression? And this is possible. So the idea is, how do we do that? I let S to be 1 plus R squared, R to the n minus 1 and R, right? So I'm going to multiply S by R. Then I find out the first term with R times 1, R times R is R squared, R times R squared is R cubed, and R times R to the n minus 1 is Rm, right? Okay. Then you see that this long group, right, of terms are identical. So if you use a subtraction, okay, equation 1 minus equation 2, then you will see S minus RS is going to be the middle term is all gone, right? Right? Then only 2 terms left. Wow. See? And then term on the left-hand side is 1 minus S. You factor S out. Okay. Finally, you've solved the problem. You find the formula. Okay. So what does that mean? That means we have the following important fact: 1 plus R squared, R to the n is going to be this. Okay. Or if you change the sign, it can be like that. You know, we can change the order, right? Okay. Doesn't matter. So R is not necessarily less than 1. Okay, R could be greater than 1. Okay, this in this form because you only have finite many terms. You only have finite many terms. So for example, the most important term is here: 1 plus 2 plus 2 squared plus 2 cubed and plus 2 to the nth power. Okay, for example, let's say 2020, right? Okay, 2020. Then the answer will be 2021 minus 1. But the denominator is 2 minus 1 is 1. So that means 2000. Okay, so that means, yeah, so many terms, add them together, right? It's just equal to 2 to the 2021 minus 1. Okay, so you're surprised, right? So this number is actually more than the sum of all those previous terms. So that's why it increases very fast. Maybe you heard about a story, you know, the deal between a person and the king, right? So he's asking for 1 item, and the first day, the second day doubles that, you know, the third day double it, right? You know, so then, you know, in 1 year, probably that's a lot, okay? So that's just increased pretty fast. So this is one interesting application. Another interesting application about identity. Look at this, right? Look at this. So actually, I can change the x, right? Change it in 1 minus x plus 1, right? I can multiply this out. I can type 1 minus x times x all the way to x, right? And this is another version of identity. Okay, it's another version of the identity. All right. So this is it's always less than 1. Clear. Doesn't matter. If x is less than 1, this number is always less than 1, right? Because it's 1 minus x to the n plus 1. Okay. All right. So from here you can see that. Okay. Let's in the above identity, right? You let n go to approaching infinity. Let n approaching infinity. Okay, let's look at this identity. Okay, what do you see? The left-hand side, you have infinite many terms, right? Right? Because n approaching infinity. So you just add more terms, infinite many terms. This is the concept of infinity, right? And then the right side, you see that x to the n plus power. Okay, so if absolute x is less than 1, okay, that approaches 0. So denominator is 1 minus x. So we get a formula. So this will be 1 over 1 minus x. Okay, this is the interesting formula. Okay. Okay, it's if x absolute x is less than 1. All right, let's look at let's apply this formula to the following example. Okay, for example, 0.9 bar. Okay, what does that mean? Okay, 0.9 bar is my favorite example. So 0.9 bar is 0.99999, right? Keeping right. So in other words, every time I want add 1, actually I'm adding another number to that, right? Every time I write 1 more digit to 9, actually I just 1 term plus another term. And then plus, if I add the third digit, right, and get this. So I get a sequence of terms, adding them together. So you can view it as a series. We call it geometric series. And the first term is 9 over 10. The second term is 9 over 10 squared. The third term is 9 over 10 cubed, right? And keep it going, right? So I can factor 9 over 10 out each term. So I get 1 over 10, 1 over 10 squared, and keep it going. Infinite many terms. So now we have the formula, right? The formula says that R here is 1 over 10. So this should be equal to 1 minus R, right? About formula, right? Look at the top. There's a formula on the top, right? So let's simplify it. And the denominator is 9 over 10. So cancel it out. This is the answer is 1. So in other words, 0.9 bar is always equal 1 in mathematics. Okay. The left-hand side means the limit of 0.0999999. When we talk about infinite many terms, it really means the limit, the constant, okay? Yeah, 0.9 bar is going to be the limit of 0.999, and here n many digits, okay, as n approaching infinity. Okay, this is about the digit stuff. Okay. Okay. So what I'm gonna do, what I'm gonna do today is I'm gonna discuss a problem. So here's a question. Okay. you have a unit square, okay, and you divide it into how many? Oops, stop working. I have to close it for some reason. Hold on. I have to restart the program, the page. Okay. Just a second. Something's wrong with it. Okay, that's okay now. All right, so here's the idea. You divide it into each time into this part. Okay? Then I color it the four corner. Okay. Then I continue to work on the middle one. Okay, I'm going to erase this, and then I do the same way. Oh. One, two, three, 1, 2, 3. Okay. Then I color those four corners. Okay, and just keep it going, this procedure. The question is, what is the total area of the shaded region? Okay. Okay. In this picture, and this is a unit square. Okay. Now, to solve the problem, we needed to assume, denote the area. Okay, so we let AK denote the area of the four squares. Okay, four squares at the case step. Okay, how about like that, right? Step 1, step 2 in the grade. So you will see that all I have to do is to figure out this formula in general, right? Then add them together. The total area will be, right? The total area will be A1 plus A2 plus A3, and then all together, right? Okay. So we have someone already figured out this. Well, let's try. Okay. So how do you figure out this? Anyway. So each time, if this one, we have to figure out the age length, A1, right? So A1, you see, 1 divided by 4, right? Because it's unit square, 1 divided by 4, right? So that implies this will be 4 times A1 squared. The reason is you have 4 same square there, right? So it's 4 times 1 over 4 squared. This is just a quarter. That's the first one. And we figured out general formula. So A2 is going to be a quarter, because this will be 2A1, right? Then you divide by 4. 4 and 2A1. Okay, and here divide equal, right? And that is going to be half of A1. Be careful, yeah. So we get the formula that implies A2 is 4 times A2 squared. Okay, let's figure out the formula here, and we can get a general form. So 4 times A2, yeah, A2 is half of A1 squared, right? Right? So actually when you square it, it's just A1 squared. Okay. All right. So just A1 squared. So we keep it. Okay, we're not going to write down the number here. So then A3, repeat the same procedure. Is going to be A3 is going to be is going to be 4, right? 2A2 divided by 4. It's half of A2. Okay, but then the total area is 4 times A3 squared. So 4 times half of A2 squared, and after that you get A2 squared. Okay. So so A1 actually is going to be So we have we got the general formula, right? So you can see that in general, AK is going to be half of AK minus 1. And capital AK is just AK minus 1 squared. Okay? So we have to find the formula for AK, right? It's a general formula, right? So then you see that I think A2 is 1/2 of A1. I'm not going to multiply this out, just keep it this one. Then A3 is half of A2, right? And so 1/2 square, 1/4, okay? And keep it going. So AK is going to be 1/2 of K minus 1 times this. So if we want to combine them, we can get 1/2 of K plus 1. So you get this formula, right? Once you get this formula, then you get AK, right? AK is going to be, AK minus 1 squared, okay? So AK minus 1 is going to be 1/4 is K squared. So when you move this, it's going to be 1/4 of it, okay? So you double check A1. A1 is 1/4, okay? So what you have here is total area is A1 plus A2, and keep it going. So that's 1/4 plus 1/4 square plus 1/4 cube, and keep it going. All right, finally, you will get, right? And then you replace it at this number. And here's 3/4. Right, so after you simplify it, just 1/3. That's what I got. I'm not sure what you get. Right, so actually it's 1/3. That is not it's about 1/3. Yes, great. Okay, so the key point is you have to find the general formula for the total area at the case step. Okay. Right. Now our next problem, we have the geometric sequence. Now what is geometric sequence? Well, geometric sequence means you have the you have 1, right? A1, A2, A3, A4. They are the consecutive terms. The ratio of the consecutive terms are all the same. They're all equal to R. Okay. So in other words, A2 is going to be A1R, right? Okay. So A3 is going to be A2R, right? So that means replaced by this is a squared. A1 times R squared, because when you replace A2 by A1R, right? So finally, you get a general formula. It's A1 R to the n minus 1. So a geometric sequence can be also written in the form, okay? In this form, if it's A, okay, AR squared, AR cubed, and cube. So when we say this is a geometric sequence, it means always like that. The Y is called geometric sequence, and this is really coming from some geometric problems above, right? As you can see that. So you are given, so the following information, okay? So the sum of the first term, first three terms, okay, three terms of a geometric sequence of positive integers, is equal to is equal to 7 times the first term. Okay, and that's the first condition. The second condition is the sum of the first four terms, okay, is 45. We have to find out the first term of the sequence. Okay, so to solve this problem, right, you write down this geometric sequence in the form like that. Okay. But so the first three terms means the sum of the three terms equals 7 times the first term. And we also told that the first four terms, the sum, is 45. Our question is, what is A? Okay, find the A. So that's actually an algebraic problem. Can you try this? All right, so nice and answers, great. So you see that from the first equation, right? Maybe you have to find R first. By the first equation, you will see that 1 plus R squared equals 7. Okay. All right. So from here, you can use a quadratic formula, or you can try and solve it. Solve this formula, right? So it's going to be R, right? minus 2 and r plus 3 equals 0. So r should be positive. R cannot be. Yeah, I already mentioned that this is all the terms as a positive terms. Okay. Otherwise, that change the sign, keep changing sign. So r is going to be 2. Now, once you get 2, then you plug into the above formula by 2, right? So you have a a plus 2a plus 4a plus 8a should be equal to 45, and from here a is going to be 3. Okay, so because this is a 15a equals 45, so a equals 3. Yeah, that's how do we solve the equations. All right, so geometry sequence, I'm going to have another question for you. So here's a question. What is fifth term in a geometry sequence? Okay, if the first term is 625 and the eighth term is 125. All right. Okay, so how do you solve this problem? Well, you write down sequence, right? Okay. Now, by assumption, right, the first term is 625. The eighth term is written as 8 to the r, 8 times r to the 7th. Okay. Cannot be negative. I already mentioned that at the very beginning for the above problem is this is a sequence of positive terms. So if r is negative, then you get the sign alternatively changes. So that's why this case is excluded. Right. So once you get that, then you can, if you understand this geometry sequence, right? Then you you just solve this, right? The only way you can do is just get rid of the second one, right? A r to the 7th divided by a, okay? So r to the 7th is going to be this, and that is going to be okay. And then each of them actually has a you multiply them out. 625 times 125. We don't now multiply them out. Actually, we're trying to express some integer, right? So you will get 5 to the 4th power and 5 cubed. Okay, so it's going to be 1/5 to the 7th. Okay, then that's why r equals 1/5. Okay, and once you get r, then you get you can get what is the question? Fifth terms, right? So 8r to the 4th power is going to be, right? Is going to be that's a fifth term, so 625, and that. Okay, the answer is 1. Okay, the answer is 1. Okay, so this is about the geometry sequence, and now we're going to consider other type of sequence. Okay. So our next problem is, if the pattern continues, what is the next term in the sequence? Okay, we have 7, 25, 61, 121, and so on. Okay. What is the next term? Okay, and what is the nth term? Uh, so let's find the pattern. Okay, in general, okay, we will we'll just take a difference. Okay, so in general, we take the difference. I'm going to call the first one is A1. All A1 is always, yeah, AI denotes the AN denotes the nth term, okay? So A2 minus A1, it's going to be 7 minus 1, right? It's a 6, okay? And then A3 minus A2, that's the usual we do, okay? And then that's going to be 18. Also, the difference between 6 and 18 maybe just 3 times, right? So A4 and minus A3, 61 minus 25, right? Which is 36. Okay, then A5 minus A4, let's finish all of them. So 121, 61. That is 60, okay? So we stop here, right? So let's see this sequence. Is there any pattern there? So the first one is 6 times 1. Second, 6 times 3. Third one, 6 times 6. The fourth one, 6 times 10. Okay, now you have another sequence. Okay, that sequence, okay, is going to be 1, 2, 3, 1, 3, 6, 10. Okay, how do we get that? Okay, how do we get that? Right? What is the next one, right? So next term in this sequence, we have to figure it out. Okay, next term in this sequence, okay, it looks like you add an increasing number. Okay, like here you add 2, that's why you get 3 is the difference of this, right? And the difference of this is another, yeah, you take another subtractions among the consecutive terms. So I believe that the next term is plus 5, that's a 15. Okay, so if you can figure out that, then A5, okay, then A4 is 6 minus A5 is going to be, right, is going to be, that's a known number, right? 121 is going to be 6 times 15. Okay, after you finish that, and this A6 is going to be, 121 plus 6 times 15 is going to be 211. Okay. 211 is a problem. Okay. All right. Now, in order to find the nth term, okay, we need to figure out the nth term in the above sequence. We needed to figure out the nth term in the above sequence, and that is difficult. Okay, that is difficult. Okay, so I call it, yeah, that is difficult, right? And how do we get the next term? Every time we add a number, right? This is called, let's call it B1, B2, B3, B4. right? B5 and right. How do I get to the next term, right? So I believe that this is just a sum, okay? So you see that B2 is 1 plus 2, right? B3 is 1 plus 2 plus 3, okay? B1 is 1, B2 is 1 plus 2, right? Because added 2, right? B3 is 3 added to B2, so 1 plus 2 plus 3, okay? And so in general, Bn is going to be 1 plus 2 plus 3 all the way to n, and we do have a formula for that. Great. We do have a formula for this. Okay. So let's go back. Let's go back to this formula, right? It's a 6 times B1. A3 is going to be A3 minus A2 6 times B2. And keep it going. AN is 6 times B. I think it's n minus 1 here. Okay. Now, how can I get to the nth term? I add all together. If I add all together, all the terms gone on the left-hand side except those 2 terms. The right-hand side is B1 plus B2 plus B3 all the way to Bn minus 1. It's not too bad, right? Okay. The question is, can I add all this together? I already have, yeah, what is B, right? What is Bn? Bn is n times n plus 1 divided by 2. Okay, so in other words, Bn is going to be half of n squared plus n. Okay, all right, so let's put it in here. So 2 terms. So n minus a1 is going to be 3 divided by 2 is, 6 divided by 2 is 3. So the first term is 1 squared plus 1. Second term is 2 squared plus 2. The third term is 3 squared plus 3. And the last term is n minus 1 squared plus n minus 1. Can we add them together? The answer is yes. Okay, you have a 1 squared plus 2 squared plus 3 squared. Reorder them, right? Yeah, I don't like my setting with my pen. Haven't figured out how to change it because this setting was for drawing, so that's why you always see drawing drawing pictures. That's why you when a writer reads and there's a tail there always. Okay, so it's 1 plus 2 plus 3 plus 4 plus n minus 1. Okay. So we do need a couple formulas for this. The first term, the formula is, this is a little bit, not everybody knows the formula, okay? Not everybody knows the formula. All right, let's see. The formula here is going to be, 6, n minus 1 is n, and here's 2, n minus 1 plus 1. And that is the second term is 1/2. Okay, so that's it. After you simplify it, you solve the problem. Okay, after you simplify it, you solve the problem. So for the final answer, will be, the final answer after you solve it, the final answer will be 1 plus n minus 1 and n plus 1. Okay. Yeah, you cannot take you can take n minus 1 and n out, and you simplify to get n plus 1. Yes. Okay. So I just said that. So we needed to recall a couple of formulas. 1 plus 2 plus 3 n. Okay. So I hope we know this formula. Another formula is 1 squared plus 2 squared plus 3 squared all the way to n squared is going to be n plus 1, 2n plus 1 divided by 6. That is a pretty strong formula. Another string formula is 1q plus 2q plus 3q. Nq is going to be n times n plus 1 divided by 2 and the square. And you can double check the last formula, but how do you prove it? How do you get this formula? This is by guess and try, and people figured out this general formula. There is a, there's an interesting movie there, The Man Who Knew Infinity, okay? And if you have time, you can go to YouTube to watch it. And he's a genius guy. He can talk to the God and write down all the formulas, identities, okay? And even more complicated formulas than those. This is, I don't know. It's actually was discovered by other mathematicians. But there's an Indian guy, he called Ramanujan. Yeah, he passed away at a very young age. But he said when he was in dream, he saw those formulas. He just write down. Okay, it's an interesting movie. If you have time, you can watch it. I think the title is called "The Man Who Knew Infinity," something like that. Hey, it's a very sad story about him. He was born in a very poor family, and they did have a little house, so their parents have to lease one of the rooms to two college students. So and this boy and borrow some books and talk to this college student. He learned mathematics from them. Okay, and then he became the best, one of the best mathematicians in the world. Okay. All right, so look at the last identity. That's very interesting. It's always perfect square. So that means one cube is one square, right? And the one cube plus 2 cube is going to be 9. 9 is going to be 3 square. You see? So you always get a perfect squares. Okay? 1 cube plus 2 cube plus 3 cube. Okay? And that is another perfect square. Okay? So 9 plus 27, it's going to be 36. 36 is 6 square. You see? It's always perfect square. Okay? And if you can, I can also write the above formula in the form like this. And then nobody can believe that at the very beginning until verify this, prove that. Okay. All right, let's try. Let's try a different type of problems now. This we did here. Okay, here's an interesting problem. Okay, it's from math class. You have to be patient enough to figure it out. Okay, this is a sequence generated by is generated by the following formula. An equals the difference of the previous two terms and greater than equals 3. And the first term A1 is 2, A2 equals 5. And what is the 100th term? A to the 100. Right? Of course, you have to find the general formula. Right? So probably doesn't matter what the value of the A1 and A2. So we may be just assuming, you have to look at the first few terms, okay, and just figure out the pattern. So we can let A1 equals A, A2 equals B, okay? Then I'm going to write down a few terms to get some ideas. So it's B minus A, okay? And A4 is going to be A3 minus A2. And I get negative A. I did not get more complicated. I did not get more complicated terms. A5 is going to be A4 negative A minus B minus A. And then I find out, and it's going to be just negative B. Wow, right? It's not like the coefficients are increasing. Okay, A6 is going to be the difference of this. It's negative B plus A, so it's A minus B. Okay. So you see A, B minus A, negative B, and A minus B. So let's look at A7. A7 is A minus B minus negative B is get A. A8. A minus B. So it's B. And you see that A7, A8, right, is exactly the same as A1, A2. So that means from now on, if you repeat it, so you get the same pattern. Okay. So this sequence is periodical. The period is 6. Okay. The period is 6. If you figure out this, then the rest of the part is easy. Okay. It appears, it's repeating. So A1, A2, A3, A4, A5, A6, that's one group. Then another group is just repeating. Okay. A7, A8, all the way to A12. It's exactly the same as the previous. All right. Okay. Now you can figure it out. I let it try to finish the last part. Yeah, please work out the rest part, possible. Right. Any ideas? Okay, so what you should do is first of all add all those together, right? Okay, to see what you can get. You find out they're all equal to 0. Okay, because it's going to be A plus B minus A plus negative A plus negative B plus A minus B, right? And yeah, right? And the A minus B, I think that's a 1, 2, 3, 4, 5, 6. And you will see that this is going to be 0. Okay, so 100, right? 100, when you divide by 100 is going to be 6 times 16 divided by 6. The remainder is a 4. So the last group, you have to have the first 4 terms. Okay, so A, yeah, the 4 terms, right? And A7, 97, 98, A99, A90, and 100, right? Okay, those will be A plus B minus A plus negative A. So so what do you get? Right, you will get 2a minus 2b minus a, not a negative a, right? 2b minus a. It's the last, yeah, this is the first four terms in the group of 6, right? So that is right. Then the sum of the first yeah, sorry, what do we have to find out? We have to find out the sum of the first 100 terms or find the nth term. I'm going to find the a. Okay, so actually we also find the, yeah, the couple things, right? We find the 800 terms is going to be negative a, okay? And that is a formula, yeah. But you can also find the sum of the same time, right? The sum of the first 100 terms is going to be 2b minus a. Okay. So if you know the value of a, if you know the value of b, and you get the answer. Okay, for this problem, the sum of the first 100 terms is 8. Right? Yes. So so for this type of problems, you need just take a look at the first few terms first to get the general formula. Okay, let's do one more problems. Okay, and the sequence is generated by the following formula. Okay, but we know that A3 is going to be 3, A6 is going to be 52. Find the general term n for n greater than 4. Okay. Hey, since not much time left, let me help you to solve the problem. Now, when I give you the course material, okay, let you know that I have additional problems there. Before you do the homework assignment, maybe you look at the notes for those problems I haven't discussed yet in the class, and it covers my solution, and then trying to work out by yourself. Okay, and that's the first step to do. Then you start to work on the homework assignment. The homework assignment is usually the previous math class problems. Right. All right, so how to do that, right? We just look at a few terms to figure out pattern. A4 is 2A3 plus X. Okay, I don't need to know exact value of A3 right now. Right? And then A5 is twice of A4, right? Right? And X. So I'm going to simplify a little bit. So A squared and A3, and I'm not going to, I just leave a 2x here, 2 plus 1. I'm not going to add them together, okay? Especially when you're trying to see the pattern. Don't multiply them out. Okay? That's otherwise you don't see it. Okay? You will not see the pattern. Okay? So A6 is 2 times A5, so 2 squared, A3 plus 2 plus 1, x plus x. Okay. Then you get a cubed, a3. And 2 times 2, that's a squared, 2 squared. 2 times 1 is 2. Then plus 1 from, you see? And then you probably can get the general formula. Okay? Probably can get the general formula. So because A6 is like in that, right? So general formula is going to be AN is going to be 2 to the difference here, 6 and 3, the difference is N minus, right? It's going to be, so let's see, N minus 3, then A3, right? Okay. Okay, right? Because the difference, 6 and 3, the difference is 3. Then here, this is going to be 2 to the n minus actually 4, okay? And 2 to the n minus 5, and just keep it going. Okay, so this is a general formula. Right? And if you know the value of A3, then you can get the general formula. Okay, you can also add the last few terms together. It's going to be 2 to the n minus 3 minus 1. Here's 2 minus, all right? We remember, we have the formula combine all those terms together. So let's write down this formula. Okay, so this is our last formula, right? Okay, so question is what is x? And based on the given information, A3 is going to be 3 and A6 is going to be 56. So let's say A6 is 52, right? And that is going to be 2q, A3 is a 3, and plus 2 squared plus 2 plus 1 and times x. And I'm done, okay? From here, you get x equals 4. Okay, once x equals 4, then you can get the general formula. 2n minus 3, and we know A3 is going to be, A3 is 3, right? And then x is 4. Okay, so you get the nth formula. That's it. So that is how the idea is, okay, if a sequence is generated by a formula, you write down the few terms at the very beginning. You probably can figure out a pattern. And also you have to be careful, don't multiply them out. So like I keep it, those terms, a square and a and 2 square plus 2 plus 1, then you can see the pattern also. If you 2 plus 1, you change it to 3, then you probably, it's difficult to see this pattern, how the number increases, the coefficients of x increases. All right. So that's about today's lesson on sequences. I told you that I have more problems in the mathematical insanity, the course material sanity, and so plus the one set of homework, about 30 problems each week. So you do your best to solve all the problems, and you have answer keys there too, okay? And then if you need help, okay, and don't forget to ask your parents to send me the list of the problems, so maybe 1 or 2 right problems to me, so I can record it, and later I'm going to discuss in the class. Okay. Okay. Bye-bye.